Hi everyone, welcome back to Prieto TV and welcome to the last episode of Season 1 of Prietology. This season we've been talking about chemistry, and if you remember last episode we talked about chemical reactions and what they are, how they're measured, and basically how they are in real life and what their properties are. Today's lesson is going to take what we've all learned, including chemical reactions, and put them all together. Today's lesson is called Earthy Resources. Why this lesson? This Earthy Resources, if you see the key terms are the needs, the necessities for Earth's chemical reactions. So let's get started. So today we only have 6 key terms for our last episode. Our 6 key terms are air, seawater, rocks, metals, alloys, and fossil fuels. Without any of these, our planet would not be able to have life as we know it. So let's start with our first term, which is air. Air is a gas, as you all know. It surrounds the entire planet, making up our atmosphere, and without air, we wouldn't be able to breathe and we would die and be frozen by the vacuum of space. Anyway, air is composed of four main gases. 78.08% of air is nitrogen. It's not oxygen, it's nitrogen actually. Most of air is nitrogen. 20.95% of air is oxygen, breathable oxygen that we need. 0.93%, not even 1%, is argon. Argon is a noble gas that usually is in some light bulbs or some of those like plasma balls that contains argon, which can make cool colors. We don't need argon to live. And a very tiny 0.038% is carbon dioxide. And you may be asking, why do we need carbon dioxide? It's bad for our bodies. Carbon dioxide is actually a necessity for life. I don't know if you heard this, but it's called the carbon cycle. It's a chemical cycle that happens on the planet that it starts with animals, and then it goes with like the sky and then like plants and stuff. So yeah, that's basically what the carbon cycle is. And without the carbon cycle, we would not have life. So we need carbon dioxide. So a layer of the atmosphere, I think is called ozone. Ozone is not particularly air. Ozone is O3. You might know oxygen, our oxygen that we have in our world, as O2. Ozone is O3. You can't breathe ozone, but the ozone layer protects the planet from solar radiation. So like all the alphas and betas and gamma rays and anyway, all the radiation. So because the atmosphere and all the air is a mixture between different gases like nitrogen, oxygen, CO2, argon, the heat sinks to the ground evenly because of the mixture of gases. Okay, so our second term is seawater. Seawater is, well, basically ocean water, seawater. So it helps keep the Earth's temperature steady. So if there's like some Earth temperature differences, seawater is a major part in leveling them. Earth is 97% seawater. All seawater is undrinkable. So that's why we have such problems today of getting fresh water and why it's such a major world problem right now. So like I said, major world problem, seawater is a major world problem because it's undrinkable, because large concentrations of salt in the seawater can cause severe conditions or death to the human body. Seawater is usually filled with NaCl, which is sodium chloride. I don't know if you heard of that, but if you have heard of that, I'm pretty sure you know what it is. Sodium chloride is table salt. I'm pretty sure you guys have used salt before in your lives. So things in that are like, if you drop like something heavy in salt water, it's more likely to float than you drop it in fresh water because salt water has an increased density more than fresh water, and we'll talk about density next season. Okay, so our third term is rocks. Rocks are solid material that make up the Earth's crust. So what you're standing on is probably a rock. I think 1,000 meters is rock. I don't know. I'm unsure about that number. Ores. I don't know if you've heard of ores, like diamond ore, iron ore, uranium ore. Uranium ores are rocks, basically, that have gems, minerals, metals. So basically that's the standard definition of ores. So rocks are made of fused together mineral grains that come with compounds. We learned about compounds a long time ago in the first episode. So basically rocks are compounds of different minerals fused together. And as you know, there are 3 types of rocks: sedimentary, metamorphic, and igneous. Sedimentary rocks are fused together sediments that come from like rivers or streams, so like they fuse together over time. Igneous are rocks fresh out of volcanoes, so like once the liquid rock cools down, it can make different rocks and minerals. And metamorphic comes with pressure. So as rocks get squeezed like under the ground because of so much pressure, over long periods of time they begin to morph, and it's metamorphic. So yeah, that's basically what metamorphic is. Okay, so our 4th term is metals. Metals are materials found in ores, like I just told you. Metals are found in ores, which are rocks with minerals, gems, or metals. So the properties of the metals, so if it's like good at conducting electricity, if it's good at conducting heat, or if it's strong or if it's weak, they all depend on metallic bonding. We learned about metallic bonding in the 2nd episode. You can check it out up here. And so usually most metals, like iron, they corrode by reacting with oxygen in the air. So like when it rusts, basically it's a chemical reaction, which we learned last class, when chemical reactions can either happen slow or fast. So the chemical reaction with iron and oxygen in the air happen very slowly, and so the iron rusts because of the oxygen. There are 3 main types of metals. There's 3 main types of metals. The first one is reactive. Those are metals that corrode very easily, like I just said. So some examples are copper, lead, zinc, and tin. Second is ferrous. Ferrous, which is mainly magnetic. Those are the mainly magnetic metals. So like cast iron, iron, cobalt, nickel, steel. And the last one is noble. They're very unreactive, which means they're bottom of the reactivity series, which we learned last class. And they're good at making dyes. So gold, silver, and platinum, those are all metals at the bottom of the reactivity series. Okay, so our 5th term is alloy. Alloys are man-made metals. An example of a man-made metal is steel. Steel is a combination of like, I think iron and, oh man, I'm forgetting the other one. Oh well, I know it's mostly iron and sometimes some chromium. So alloys are made by melting 2 metals and combining them. So like if you put iron and chromium together, you could get steel. And if you put more chromium, I think you would get some better, stronger steel. So that's what they use to make steel. They use chromium to make it like rustless or stronger. Alloys have a melting range. Instead of like a melting point, which is like 1 degree of where they would melt, alloys have a range of temperatures at which they would melt. They can also help give metals better properties. So like I said, in the case of steel, chromium helps give steel better properties. So like they can make them stronger and so they don't get stained, like stainless steel, so it doesn't rust. Okay, so we're on to the last term of this lesson and the last term of season 1 of Prietology. So our last term is fossil fuels. Fossil fuels are carbon compounds made where there is no oxygen in the ground. So they're carbon compounds buried where there's no oxygen. So mostly there are 3 main types. There's coal, oil, and natural gas. Coal is, it's a rock, and it's actually, hold on, let me think. It's a sedimentary rock. I have to check again. Oil is a little dark liquid. It's crude oil made by like decomposing fossils and plants. And natural gas usually comes from extracting crude oil. So when you what's the word? Refine. There we go, refine. When you refine crude oil, you get natural gas and petroleum. So when they react to make energy that's used for electricity, they react with oxygen in an exothermic reaction. We learned what exothermic reactions are. Those are reactions that give off stuff, not suck energy in. So they give off energy in the form of like heat or light or electricity. So burning them releases sulfur dioxide and carbon dioxide, which is obviously not good for the environment and for humans. So that's why we're trying to move on to clean energy sources like hydro, solar, wind, and geothermic instead of coal, oil, and natural gas. Well, I think we covered all the key terms for today. truth is, I couldn't find a science experiment for today because our topic today was not super sciencey. It was just about the different things that make up the Earth and stuff. So I guess we will have to end Season 1 experiment list. So this concludes all the chemistry lessons for Prietology and Season 1. There will be no more chemistry lessons for Season 1. Our next topic is physics. And also, I will not be uploading videos June and maybe not July because of something our family has to do. It's not traveling because we're in the middle of a pandemic. And also just I want to take a break from making videos. So I'll start making videos sometime around maybe mid-July to early August. So thank you for watching. Like, share, and subscribe. Get this video to the front page and I'll see you later.